Yeah, I think it's working. Who knows? Yes. Mm-hmm. Mm-hmm. Just gonna share some link on the internet. Forgotten how to do this.
And feel free to follow it.
No, Twitch. Oh, good. Now I'm gonna watch my own stream and get feedback. Is that working? Feedback? Hello? Hi. Is this working? I don't know. I don't know if this is working. I'm gonna see by watching my own thing. Oh, yep. There I am. Is sound coming out though? Hello? Hello? I don't hear myself, so I'm not sure. Interesting, but I see a volume meter. Why wouldn't I be able to hear myself? That's odd. Checking. Yep, joined. Oh, can you hear me, Janus? Can anyone hear me? I cannot hear myself, but that's fine. Hello, hello. Hmm. Oh, okay. Great. That's good news. Well then, I will get started. I am going to talk about macro stuff. We'll see what happens from my tiny little video over there. Yeah, so I'm just gonna dump all of my brain out. I'm not in full peak caffeinated, eloquent mode, but we'll see what I manage to piece together. I have about an hour and a half, I think, maybe a little longer. So I'll do what I can. So yeah, let me know if there's anything you want to know about in particular, and or if I say stuff that just doesn't make sense. But I'll try to start from the beginning of macros. Ignore what's on the screen now. It's not very much related, even though I might make it related later. I just have some project open. Um, but macros are cool. They're another form of abstraction, one that is maybe a little less principled and a little hackier than just doing sort of type level code generation. There are few ways of saving yourself time with Scala, right? One is by writing nice sort of combinator libraries, but not everything can be turned into a combinator library, or it can be, but then there's a little bit of sort of overhead That's not as nice. I think one example is this the Zeo Magic thing that I've done. Let me share my screen. Let me also add a friend. It's important to add friends. I'm your friend, Janus. Yay! Um, so let's talk about this. This is a good example of a potential motivation for having macros in the first place. This is the first macro that I made, at least. Um, oh, the meeting room. The meeting room. Yes, I am. That would be great because then I could talk to you. Let me see if I can do this. Other participants? Where does this go? I don't see any. Oh. Hi. Greetings. Hello, hello.
Hello.
Hey. Sorry
Hang on,
about that.
I'm gonna.
Let me make this into there we go. Nice
Sorry, I
gallery.
just turned you off on Twitch. 1 second. It is not letting me use my headphones.
Gotcha. Yeah, let me also I think last time I tried to
Yeah.
do both Twitch and Zoom.
1 second. Sorry.
Oh, sure, take your time. Take your time. I'm gonna turn off the computer audio and just have my speaker audio. Because last time I checked, when I did this with Adam, he was doubled and had this cool reverb effect that was probably annoying.
Hello.
Greetings.
Why are you doing this to me, Zoom? Sorry, I can't hear you.
Oh, no worries. Take your time. Well, I guess you can't. Oh, I'm muted. I'm muted via Zoom.
Oh, right, that'll do it.
Not anymore. Not anymore. Hopefully, it works on the internet. I don't know. My computer's gonna explode and everything's very silly. But hey, awesome. So it's so much better than talking to myself, having another person. So, hey, Darcy or Janice.
Hi.
Greetings. Yeah, how's it going?
Yeah, really good. Really good. It's freezing cold outside. I live in the foggiest city in Australia, and it shows. But I guess it's not so bad this morning.
What freezing cold by Australia standards, or well, I guess it's gonna be Celsius.
I mean,
So.
actually, I don't know if this is cold by US standards either, but it's temperature right now.
Yeah, if you could translate it into
It's 3 degrees centigrade. So I don't know what that is in Fahrenheit.
okay, that's definitely cold though because zero is
It's
freezing,
cold.
so it's it's not good. Well,
It's close to the beach.
I'm sorry.
Dear. Also, interesting fun fact. I think you have the exact same IntelliJ setup that I do.
Oh, you got Atom One Dark.
But, yep, I sure do.
Nice. Yeah, I think it's my favorite. There are a few themes that I like, but I think this is the one I keep going to. I just like it because everything is colored. Everything that could possibly have a different style has a different style. Like the default, everything's gray, and some things aren't in italics, and that's not nearly enough differentiation for me.
Hang on. Oh, that was YouTube.
Cool. So yeah.
Alrighty.
I was gonna do a brain dump on macro stuff.
I'm ready.
Okay. Okay. Awesome. Have you used macros before? No.
Nope. Never
Okay.
ever.
Are you familiar with the use of Mac, or maybe not how they work, but do you know which? Sometimes it's hard to tell which functions you call that are using macros versus which aren't. But are you familiar with any like macro libraries that you use currently, or?
I've actually never explicitly used macros at all. I may be using them implicitly, and I don't know. But
Probably, I assume some. Lots of. I don't even know all the macros that I probably use. Yeah, lots of libraries use them for like little niceties, but it's hard to say.
Okay.
But yeah, there are. So yeah, I was just going to start by talking about. Well, the reason I had started using macros in the first place was because of a pain I was experiencing. I wrote this library called Zeo Magic, which is intended as sort of like a dependency injection. Have you used Z layers before?
Yes, I actually got to using Zeo at work, and a bunch of stuff it made. Like This is going to sound terrible. I was trying to do interop with Akka Classic. Yes, no. And it's fine. It works perfectly well, and so like the creation of the actor system is done in the Z layer. I have another Z layer for wrapping queries to Elastic, and like post to Elastic and stuff like that. So yes, I have.
Nice. And so
And they were
you've probably done something like this with the sort of layer composition operators, or maybe not.
yes,
Okay, yeah.
yes. Mine was like strictly horizontal, but yes, like they're all. Yeah, I don't think any of them depend on each other, but yeah.
Nice. Yeah, that can be easier if it's all just pluses or arrows. But when you sort of have to get these more complicated branching and wide and deep layer graphs, it gets a little more complicated.
Yeah, absolutely. I actually watched your video on Z layers as one of the
Oh, nice.
where you're explaining how they're like collected, how they're acquired in parallel and all of that.
Yeah,
as
yeah.
much as possible. Yeah,
Yeah,
that was great.
the Z layer thing. Oh, yeah. Okay, yeah. Yeah, I kind of talked about this there. Yeah, because they're very cool. I love them. I mean, they're one of the first things about Zio that was like blew me away and got me hooked on it.
Yes.
However, they do come with a little bit of pain in the construction of them, right? It's not the it's actually it is a lawful and intelligent combinator library, and it makes sense how you compose them as long as you figure out sort of the relationship between these operators and the graph that you're building. And the only problem is if you screw up, as I show in the docs here, if you accidentally leave something off, you get this giant type mismatch error, which just practically
Yes.
speaking is not nice. And it yeah, I mean, you could imagine a world where the Scala compiler gave better output. Maybe it would be a little nicer, but currently, as it stands, well, very practically speaking, I was at a job where I had some coworkers, obviously, as you have in jobs, and they ran into this problem all the time. Like I introduced Zio, I was super excited about Zio, but then in test code where they had to build different layers, I would constantly get called in to sort of help debug these errors. And I got pretty good at debugging them. Generally, the first step is just like ignore this entirely. Just take it as like there's a sign that something went wrong, and then investigate the types and sort of figure out what you're missing and break it apart into sub layers and so you get more constrained error messages. But it's still hard and a
Yeah,
pain,
definitely.
and it could be nicer. So
Yeah.
I thought there was an opportunity because I know that there are other libraries like Juice that do similar things at the larger level, this dependency injection where they figure out what's missing and they don't give you the greatest error messages, but there's some kind of I knew it was vaguely possible with macros, and so that's where I started to learn about macros. I tried to do it, and it was actually surprisingly easy. My cat might yell in the background. She's in heat again.
That's okay.
We're getting her spayed very shortly, and I'm very excited for that.
I'm hoping one of my cats will come in now. So.
Oh, good. Yeah. Maybe we can introduce them. Matchmaking. But yeah, so the idea is that this is shitty. Perhaps if you had the information, you could do something like this. Like macros are all about generating code. They all operate on syntax. They're transformations of one abstract syntax tree to another abstract syntax tree. So a macro gets an AST that of all the arguments you pass into it, and it has the option to generate another AST. So it's kind of it's simple in that regard. It's simpler than one might think about it. It comes with some like you kind of got to rewire your brain a little bit. Um, I found it similar. I had a lot of sort of a difficult time when first getting into sort of type level programming and using sort of the implicit tricks to write type level functions and inductive type level things. You can do some cool stuff like that, but there's this sort of difficulty I think when you first get into using a lot of types. And your brain has to differentiate between the two worlds of runtime and compile time values, and they're very much two separate. There's a hard, impenetrable line between them.
Yes. Yes.
And at the beginning, I felt myself like wanting to reach over that line a lot, just like, oh, why can't I have that information? And eventually, you practice and you realize where those boundaries are. But there's no. I think people who practice it and get used to it forget how hard it was to realize that boundary.
Yeah.
Yeah, that sounds okay. Good. And
Oh no, I'm like, yeah, I'm definitely on board. That like
yeah, it's pretty
that makes
painful.
a lot of sense.
And it's a similar thing with compile macros, because there's this boundary between compile time and runtime, and it's a similar thing. And things that you want to grab hold of, maybe you don't quite have yet. You have the abstract syntax tree of a value, but you don't necessarily have that value itself. And sort of differentiating between those two things, and getting an intuition of what you can actually do at what time takes some practice. Um, but that's kind of the only real tricky thing about it. That plus the syntax plus the API is a little not so ergonomic. It's sort of a low level compilation library, that's a compile time library that isn't as nice to use as say Zio's API. Um,
Okay.
but it can do
Yeah,
a
yeah.
lot. So you just have to reach around a little bit, and you can figure stuff out. And there is some documentation, but not nearly enough for how complicated it is. So you kind of just have to investigate other people's libraries. So I made a big habit of looking at like libraries like Monocle and Chimney, and what else? Gosh, uh, basically every library that I could think of that had macros in it, I peeked at some point, to get some ideas of like good patterns to follow.
Yeah, yeah.
But the idea is for this one is actually quite simple, where we want to build ourselves a layer. So the idea is you have some program, and it's a Zio, and that Zio has some requirement. So it needs console and it needs cake, and and therefore, in order to run it, you need to provide it a console and a cake. So each layer itself also has dependencies. So if you, I thought, okay, maybe I could make a macro that you give it a layer that, or a series of layers, and then let's say one could imagine if you had a function going from a, an AST of a layer, which has type information of it. So let's pretend types were just values. And that's kind of the tricky part. Types are values at compile time. You can inspect them, you can transform them. And so if you had a macro where you could grab the types out of a layer, then you can sort of build a little graph and say, okay, you gave me this layer that gives me a cake, but it requires flour. And then you could say, okay, well, did you provide a layer that provides flour? If no, then you could just bug out and throw an error and give a nice warning. Otherwise, you could take that layer and then look, does it have transitive dependencies? And let's do a little graph traversal algorithm. Um, so really, if I go, let me open up Zio Magic actually, and I'll show you like the core of it. Like the actual logic is uh, totally abstracted from macros. It's just this, there's this graph thing that has all of the logic, which is kind of cool. And it actually can be used for other things as well. Let me see. Graph? Yeah, it's just called graph. So it's really only 60 lines long, like the core logic, and it's only complicated because of I wanted to uh, have some nice error handling. So if there's a cyclical dependency, I wanted to throw that as a particular error. So if you have a layer that depends on a layer that already depended on it, I want
Right.
it to be like, okay, now this is going to infinitely
Yep, yep. It'll
loop.
be like, hey, this graph contains a cycle. This is a no go.
Exactly. Exactly. And same with, I wanted to collect all the errors, like a validated type, instead of just, I wanted to, yeah, instead of just throwing one error at a time, I would like to gather up as many errors as I possibly could and present them to the user. So, like, you're missing this and this and this and this instead of going one at a time. So, in order to do that, I
Yeah.
need to sort of make my own little custom validation type that just collects errors. Um, but really, what a graph is, it's a bunch of nodes, and there's some extra complexity because of reasons. But
Yep.
uh,
Okay.
it sort of slowly got more complex over time. But a node is just, this is just like an individual layer in one sense. So there are a layer might be, I'll call it a UR layer that gives you a cake, and it needs, let's say, A with B, right? So that means that node will have as inputs, it'll be a list of literally like A and B, and then at its outputs will be a list of cake, and then its value will be like the actual expr of that layer. It'll be the syntax tree. They're called expers, but this is this is like a typed syntax tree. So that's what that is.
Okay.
And these are actually going to be these. They're going to be these types. Cake is going to be a type, which is just a value representing the type of cake. So when I use this to generate a graph, these get hard coded to types and expers, but they have values and they can be compared and all that. So what I do is I look, okay, so I say I want to build a graph for these outputs. So let's say you called inject on a program that needed cake and console, then the outputs would be cake and console. And then it would look through its nodes and it would call for each of the outputs. So let's say cake, it would say, let's get the node with that output. So you give it the output and then it tries to find it. So it literally goes through the nodes and it tries to find one where the output has a key that equals that output.
I see.
And it has to be this because types have a strange equality, and so that's why I parameterize it by that. Because if it's a type, then I need to have like underscore equals underscore. Like I check if they're subtypes or something. I forget what I do, but it's something else. But really, that's it. And if I don't find one, then I return an error, and I let it for this case because I try to find nodes in different different contexts. I parameterize this function by an error type. So at the beginning, I fail with missing a top level dependency because this is like a top level dependency that's missing. But if I try to get a dependency, I throw a different error saying missing transitive dependency because now I'm missing a dependency of an already existing node. So now I get the output for each of the nodes input. I try to get the output, and then so I'm building this tree recursively. I'm doing this recursive search, and then when I get to the bottom, I just kind of percolate back up, and I have this this type back. It's actually a free structure. I don't know. Did you happen to see John's recent talk that he gave at Functional Berlin?
No.
It's pretty great. It's called, what is it called? Freedom? I forget.
Is that the type level?
Yeah, it's like building without type classes. What it's called.
That's the one. Yeah.
But one of his recommendations is to use free structures, and that's basically just like a data type. It's instead of doing like a type class, you have just a data type. So what I do is I return from this layer compose type, which looks very scary. It's just a sealed trait, and it has 3 values. It has compose horizontally, compose vertically, and then it has like the ability to lift some value into it. So it's kind of like a data structure that represents the pattern of composition of layers. But it's not evaluated. It's just a data type, which means that at the end, I can call fold on it and tell it how to interpret it into some final value. So I take the actual layers and turn them into some B type. And then for each compose horizontal, I give it a function for telling it how to interpret what sort of like you can think of this as an abstract syntax tree specifically for layer composition. And
okay. Yep.
And it's just a nice way of like allowing this graph thing to be totally just to return a value, and it doesn't have to know about building the final layer expert or something, building that final abstract syntax tree. It's just going to return a value that later on, after I get that value out, I can fold that with macro code that will build a new abstract syntax tree, actually calling the plus plus operator on layers to do that. So this is going to give me this value type that represents layer composition, and I'll reinterpret that as an abstract syntax tree. And it's kind of interesting. The actual way, let me see how do I do this. Where's my code for this? Builder, expert graph. Sorry. Yes.
Right, expert graph, yeah.
Yeah. And so it's kind of complicated because this is totally this works for both the same data types work for both Scala 2 and Scala 3 macros, which is kind of cool because it's totally generic and it's parameterized by everything. So that was kind of another bonus reason for having everything be abstract internally, is that the actual core of the algorithm I didn't need to rewrite. I could just share the same graph traversal, and really only the data types that I turn them into have to be specialized for Scala 2 and Scala 3.
Oh, nice.
So this thing is in charge of building a complete layer for some outputs. And if it fails, it reports these graph errors in a very nice sort of way. So it's like, it colorizes them and say, hey, you're missing this for this. You're missing this. Hey, you have a circular dependency,
Yeah, yeah.
et cetera, et cetera. So what builds this is where it gets parameterized by like how to actually combine the layers. So this is actually now in like macro code world where I'm saying that how I'm interpreting the horizontal composition, this is how I'm going to fold over that composed layer structure. I'm going to interpret that horizontal composed data type, which is really just a case class that has a left and a right side. I'm saying take the left-hand side and call this operator on it with the right-hand side. And this is a Z-layer operator. This is literally making a new abstract syntax tree, calling, if the left-hand side is an abstract syntax tree of a Z-layer, it's going to call this on it, and with as the right-hand side argument, the other Z-layer. So this is literally just returning a new abstract syntax tree. It's just really like you could think of it as coding with sort of strings at some point. Like it's not actually strings, but it's like it's a case class. But you can, with this quasi quoting syntax, this little Q, you can represent it as strings. But it's kind of just it's as simple as string programming, really. It's like you can think of it as like, oh, I get the codes, I get the literal code string, and then I get to inspect the types of that code string, and then rearrange it in some way.
Nice.
So literally at the end of the day, I when I call this, I am actually ending up with something almost identical to this, except a little fancier. Yeah. So let me go to the actual top level, and obviously it's gotten more complicated over time, so it's a little hard to understand everything. Let me go to
I was gonna say I'm not quite taking in every kind
no,
of
of course not. No, there's
part
there's
of the
there's a lot of details. Yeah, so let me show you where it begins. So yes, so this is in Zio Magic, so everything has to be an implicit class because I don't actually own Zio. It's an external package in here. I've since re-implemented it and it's pushed into Zio 2.0 branch, but it's yeah. So what you do to call a macro is you have a method that's just like a normal method signature, but then instead of actually implementing it, you write this word macro, and then you then you call what looks like a method, but is actually a macro definition. And there's this pattern that has to exist that's very strange, but it's just what you do, where the macro definition in Scala 2 has to basically mirror the function site definition. It has to have like literally the same names of the arguments and same return type. So notice how this is a function that takes this inject function takes a var args of z layers and returns a zio where the r has been turned into an any. So this is an implicit method on any zio of rea, and then by calling inject with some layers on it, we're going to get back a zio of any. And then the actual definition of this is the same type. It takes layers and it's a varargs almost of layers, and it returns almost a zio of any. The only difference is everything is wrapped in expers now, so the pattern is that it has to be the same shape, and except that they have to be expers instead. And also, because things have gotten so generic and I wanted this to work on also Z managed and other things, I accept as a type parameter the value, the type that it's going to return. So that's why there's this like F here that has three holes, and I'm saying I'm going to get back a Z exper of F. But in our cases, for now, this is a ZO, basically. So it's a little complicated, but so we get these layers. And these layers are it's basically a list of layers, and it looks like we've thrown away all the type information, but because it's a macro, we can actually inspect these layers. So let me dive somewhere interesting. Yes, so I'm taking these layer expers, which is just these. Each one is an exper is a typed abstract syntax tree. So it's just like literally some sealed trait hierarchy of like values and blocks and whatever, all the entire abstract syntax tree of Scala represented as a case class hierarchy.
Nice. Yep.
And it's also then sort of given this phantom type essentially of this, so you can know that this is an AST of a Z layer. And even though there are no types in here, it actually holds inside of it. It's just a value, really. It has as values types inside of it because it's already been typed by the compiler. So macros kind of slip in there after the typing phase. It's going to give you the typed abstract syntax tree. So in here, I call for each layer, I map over each layer abstract syntax tree, and I call this get node function, which returns one of these nodes I needed. Except now that node is parameterized by its keys or types, and
Yep.
and its values are the actual typed abstract syntax trees. So in order to do this, I call on the layer, which is just that abstract syntax tree. There's this actual type method. I think there are many methods to get a type, but this literally gets you the type of a code expert. And then I call dalias on it in case it's like a task or a UIO or something. This will get me, you've got to, you'll literally get like an alias and then you won't have the right information on it. But I want to make sure it all gets turned into Zio and it's not some alias.
Rather than like a UIO or some other.
Exactly. You've got to be careful. That's one of the things, like, there's so many methods and you've got to hunt through them. But I figured out that this works. Maybe there are other ways of doing it too, but this is fun.
Yeah, fair enough.
And there's a method on types called type arguments, which gets you a list of types.
Oh.
And because I know at this point that this is a Zio, I sort of unsafely grab out of here the input type and the output type, which I am enforcing are going to be things like has int. So in is going to be something like has int with has string with whatever. Let's just say that. And the output type might just be has cake. But what I want is to get a list instead of just int with string. And here, I want to get a list of just cake. I want
to. How come your arrows are nice in Unicode?
Because I downloaded a library for my font that has ligatures. Yeah. It actually it's very beautiful, and I'll pitch it. Monolisa. I like it so much.
Monolisa.
Yeah, I probably won't be able to find it if I just search for that. I'll look for Mono. It is $70, which I don't know. I shouldn't have done it. Who spends money on a font? But it's so beautiful, and it's like a little wider than normal fonts. I don't know. It was a total probably waste of money. I was
gonna say it looks very nice.
It's very, and they clearly they think about. Oh, it's so gorgeous. They have a look. Oh, the effort they put into. Yeah, but they have coding ligatures, which is fun. I mean, there are other fonts that have coding ligatures that are free. I don't know. I bought it for myself for my birthday. I splurged. I couldn't resist.
Fair enough.
But great question. Look at the K's. So weird. Why is it like that? I love it. Almost looks like an R, actually. But I can't use it.
It does. It looks like an R with just a little.
Yeah, maybe that's terrible. It does look like an R to me now. What the hell? Care? No, anyway, that's cake. Now I'm freaking myself out. Okay. So what these are at this point is I'm getting the type, which is like, it's a type, but this is a type at the value level. This is like, type is now a value. It is some type member of this types thing. Like you can't actually look at the actual implementation because it's hidden beyond this trait. But when you do macros, you're going to have a type, and you always operate on them through these these other traits. So an expert, yeah, you either operate it on through implicit classes or traits. So you can't actually see the actual underlying implementation. But the point is, it's still a value, even if you can't match on it and get all the actual concrete case classes.
That's that makes sense.
But it's still, the cool thing is, though, it is like an actual value that you have. So you can call type args on it, get the type args out. So I want the input and the output of this, what I know to be a Zio type. And then what I'd like to do is this transformation. So I have this get requirements method, which takes a type and returns a list of types. And so I actually made a little implicit class, I believe, on types. So type ops. And I have this intersection type. So given a type A with B with C, you get back ABC. And so on the type, which I've called self, I call dalias once again because I'm paranoid. and I keep de-aliasing everything just in case it's another alias because I ran into problems.
Fair enough. Fair enough.
At some point, I called it like 8 times because I was so scared. But anyway, and then a refined type is, it turns out, what has so that's a sub. What is a refined type? A refined type is it's a subtype
It's
of
a
type.
type with like a constraint of some kind, or
Yeah, yeah. It's it can have lots of constraints, but it also happens to be anything that has width as well counts as a refined type. So there can be lots of
I see.
things. There's some examples. It's not always the best. I think it could be other things as well, but it's kind of like an intersection type. And parents turns out to be the list of the widths. So
Ah,
so I call parents and then I flat map on it again, calling it recursively until I've sort of flattened out all of the has types. Maybe that doesn't even make sense and I shouldn't do that, but it hasn't caused me any problems yet.
oh,
Yeah, I wonder if that would be a problem if a has contains a has. I don't think so though.
fair enough.
Okay, yeah, I think it's. Oh yeah, I know why. In case there's a width, but one of them is a type alias, and then so I'll de-alias that and then keep expanding. So I really try to flatten out the intersection types into a list.
Oh, okay. Yep.
And there's some other thing that I'm doing here where there is, I don't even know why I did this, but there was some edge case I ran into where there was like some type bound thing and I needed to just get rid of it.
Okay.
I don't even remember why, but that happens. And you'll see a lot of these hacks when you look at people's macros libraries because there are like little edge
Yeah,
cases.
fair enough. I was wondering about that. I'm like, surely the first case covers
Surely
basically everything you want to do, right?
it would be lovely if that were the case, but alas, Scala has a very complicated type system and it doesn't quite. Yeah. Yeah, it would be nice if someone wrote like a generic type API on top of types, on top of the macro library, so you have like a nicer, higher level API. But I don't think anyone's done that yet, just because not many people write macros, and everyone kind of just works through the
That's fair.
same
That's
edge
fair.
cases. That would be a goal eventually, but maybe I'll wait for just Scala 3 instead. Okay, but anyway, that does that last thing, and so I get the type members, and then what I do is yeah, if it's a has type, so I get all the types. I filter out if they're has types. So I get the type, I get the type symbol, and I check to make sure that's equal to the type of has's type symbol. So that's just a method that exists that you can call. You can get the value from a type. So it sort of like implicitly gets the actual type value, and then I'm making sure that both of the symbols are equal. I'm not sure if I need to do that or not, but whatever. Um, so now I have a function that will tell me whether or not a type is actually has. So, and if there weren't any has types, like if so, I'm filtering out all the non-valid has types. Then I abort the macro and throw an error saying this contains non-has types. You're only supposed to use this with this is like an opinionated high-level thing. You're only supposed to use it with has types, otherwise it blows up. And then I de-alias the has type, get the type arguments of the has type, which is the list of the parameters, and get the head of it, which is going to be the thing contained. I know it's going to be safe because it's a has type, and it's so you got to be a little, it's kind of dynamic and not safe, but it is safe because of that check. It's hard to write very safe macros, but yeah. So I'm kind of just operating on macros, and so I just get it into the shape of those nodes, and then I pass those nodes into the graph, get back that other structure, and then at the very end reinterpret it into a new syntax tree. So it's kind of just like a parser, transformer, pretty printer kind of pattern.
Oh, yep.
Yeah. So yeah, get an ASTs, get out a
Hmm.
graph, get out a layer compose value, and then process that, fold over that to get a new AST. And so it's kind of a flat list of layers, L1, L2, L3. And then at the end, we're going to get back after all those stages a new AST where they're built together as they should be, whatever that means, based on their types.
Yep.
So yeah, it was there are much harder macros to write. This one actually turned out to be pretty easy because I didn't really need to inspect much. I didn't need to parse the actual syntax that the user wrote. I'm only operating on types. I don't really care. I'm not trying to transform different
Yeah.
Like Quill, for instance, the database macro library, like literally has to parse all of Scala because they need to see, they need to transform
Oh no.
filter into some other internal representation and then do all sorts of shit. So
Yeah. I've never used it, but bear in mind that like I literally have only been using Scala for like 5 months
nice,
now.
nice.
5 months, 6 months.
How do you like it so
It's
far?
been good. It's good. I actually like one of the reasons. And I talked about this with John in our 101, but I chose Zio over something like over like Cats or Cats Effect because the first two were too much like Haskell, and I'm like I don't actually feel like I'm getting the full benefits of like what Scala
And
has to
you
offer
came
in
from
terms of
you used Haskell previously, right?
yeah. But there are kind of things that Scala does that Haskell doesn't do, like
Sure.
actually having sort of first class support for things being modules,
Yeah.
which is very nice and is a real annoyance in Haskell. I never really used Haskell for anything that serious, but
Mm-hmm.
I did end up making like large-ish projects. And
Were there any sort of, what stack did you settle on with Haskell, or that sounds kind of cheesy. I don't think Haskell refers to stacks, but like what libraries did you end up using?
so I mean, the thing that I ended up using the most was like Servant, basically.
Nice,
For,
nice.
yeah. There was what's it called? The Servant. I think there was something called Conduit.
Oh, yep, yep, yep. That was sort of like the stream library, but
Yeah, which
Swarming.
was really nice. And what else did I use? I used Liquid Haskell a fair bit.
Wait, what's that?
I used Liquid Haskell.
Oh, wow. Ooh, fancy.
Yeah, right. Yeah. um, and that was really nice. That kind of like when you mentioned the refinement types earlier, I was like, oh hey, it's kind of like Liquid Haskell.
Yep,
But,
yep.
and then what else did I
Except
do?
way less, except way hackier. It's just macros.
Yeah, well, I don't know. Like Liquid Haskell is pretty hacky. It like has you're basically adding refinements as comments. Like it's
That's a
you
good
know
point.
there's various levels of hack, but
Yeah, it's all hacky at the end of the day.
yeah, exactly,
Have you?
exactly.
Did you ever use Polysemi? Are you familiar with Polysemi?
Oh, I remember Polysemi. Somebody's mentioned it to me, but I haven't actually used it yet.
It actually, this is why I like Zio so much, because when I was writing Haskell, Polysemi sort of standardized as my favorite way to like. I was Monad transformer libraries and MTL and the final tagless style. Like it all felt not quite right to me. I don't know. For whatever reason, I never. I loved the elegance and beauty of Haskell, but just it was hard. I wasn't satisfied with like real world programs I was making. They just felt a little too awkward to work with. And Polysemi was the closest I'd ever gotten. And it's a little weird. You got to write like a gadget to describe sort of like an API. Essentially, you're basically building an interface. So like a console interface will read and write. Write basically takes a string, returns nothing. Read takes nothing, returns a string. You can read it. You have to squint through the M part and just know that it's like an API for like you call read, you get back a string in some monad. You
Yeah,
call write, it accepts a string and gives you back nothing. So it's like reading in like console put stir line and read line, right?
yeah,
Uh,
yeah, yeah.
and then you get to interpret this into different. You write different interpreters. This is kind of like a layer a little bit. This consumes so like given this an effect that has like an what do I say yes, teletype in the environment. You can remove that teletype from the environment as long as you have an IO in the environment, and it retranslates. It literally rewrites this AST from this teletype thing into IO. So I take read line and I literally call this embed get line. So I'm reinterpreting this read as calling get line and IO. And then
Oh
for
wow.
write, I'm interpreting it as putster line. And obviously there's a lot of noise and complicated, scary type signatures, but once you get used to it, you kind of squint and you say like, oh, this is an interpreter for teletype that requires, it rewrites it in terms of IO. And that's kind of like the base monad. So you slowly like, you have this series of interfaces that you can sort of treat as layers, and you can either rewrite them into IO directly, or you can reinterpret them into a different layer. So I could like rewrite teletype as like 3 different other things, and you sort of like pass it through these different interpreters, and then when you finally run it, so here's another version of interpreting it. Instead of to IO, they interpret it to a string monoid. So you'll get an out, you get some inputs, and you can get an output. It's kind of interesting. And then you can run the same program with different ways. So it's like it's a totally different encoding. It's the version of extensible or free effects.
Oh, right, okay. I haven't heard of that.
Yeah, it's very fancy. It's very good. There are a few extensible. It's like an alternative to the monad transformer style. And you write these like you do these like little mini transpilation cycles on ASTs, and it kind of reminded me when I first came to Zio of Z layers. I was like, oh, Z layers, or vice versa. Z layers reminded me of this with a totally different encoding and totally different way of actually working, but the actual like feeling of it, of sort of reinterpreting the same code. I guess in John's terms, Z layers are more like executable encodings, and this is an initial encoding. So instead of rewriting a syntax tree, it's different anyway. But
but I do see the similarity in abstract terms.
yes, and it's very
that's very
and it's almost nicer to do it in the Z layer, where there are trade-offs, but there's obviously less of this stuff, like just frightening type signatures and certain awkwardnesses of this.
That was always the terrifying thing about Haskell once you start getting past the sort of basics.
Yeah.
The type signatures become terrifying.
Really horrifying. Yeah, I mean, I loved it. I loved it a lot, but I've definitely come around to Scala. I just need autocomplete and the module system, as you mentioned it's so nice to have. It's just so painful to have to like write your functions first and have no autocomplete and no intelligence around that. Like you have this super smart type system, but it's all thrown away when you're actually typing the code, basically.
Did you ever come across Haskell language server?
I did, and it's gotten a lot better. It's gotten a lot better, but there's like still nothing can beat dot chaining on a module and being able to.
No, there's nothing quite in that realm.
Yeah.
Oh dear. But yeah, what's the word? I'm keen. There was a lot about Zio that I really enjoyed, and I went into working on the code base that we have at work, which is from about 5 or 6 years ago. I think 6 years now. And it has what do you call it? Like I already said, untyped ACCA, which is suboptimal. And what else does it use? No, I can't remember, so let's just stick with untyped ACCA for now. And one of the things, or first things that I was responsible for was like rewriting 2 of the microservices that had gone out of date. I mean properly out of date, like ACCA, I think 2.3 or 2. Like ancient libraries. And one of the first things I noticed was like we were kind of doing the finite state machine thing a lot, and I was like, it kind of seems like we're sort of. It was very hard to maintain, so I burned it all to the ground and replaced the ACCA actors with Zio tasks.
Beautiful.
And that actually worked because it was a tiny service. But I still need to, what's the word? I still needed to use actors for some of the stuff, so some of it is kind of Z-layered away, but I kind of hope to change that out for something better in the future, and the Z-layers will make it really easy.
What are the sort of the constraints that require the actors?
They are arbitrary, but I've been asked to use ACCA HTTP.
Also, and the requirements of the sort of circumstantial requirements.
requests, and I'm like, fine, I'll use it, but
Yeah.
I don't know. I never understood why macro HTTP like it needs you to spin up an actor system so that it can make HTTP requests, but or do its
When you
its
have
routing.
when you have an actor system, I guess everything looks like a nail or whatever, or everything must be actorified.
Yes.
Yeah, actors are cool, and they're kind of you feel like this little mini wizard and orchestrating all of these tiny little machines. Maybe I think it gives people a sense of power and awe. They're running a little machine android army or something.
Yeah,
I
right.
used Erlang in the past and Elixir in the past, and it's really fun to like send little messages back, ping ping, in little mailboxes, and you can have supervisors and stuff. But most of the time, it's like really now it's just all mutable. It's all global mutable state that's sending a little. It's horrifying. It's so complex.
Yes, and I was like, I was finding that it was really, really hard to trust the unit tests and stuff that were written because I'm like, I don't know which states are possible. Like,
Yeah, it gets really complicated.
um,
I mean, I haven't tried every way of writing software, but the Z layer approach has been it's very I felt the least anxiety so far when writing it. I sort of use some strange background anxiety as a signal. Like when I did Ruby on Rails back in the day, I felt all this stress around testing. I'm like, I like Ruby, I like it's cool, but like everything feels wrong. I'm doing something wrong. Like when trying to write tests, it would be like something is deeply off here. I don't know how to write these, and there's all this stress and pressure and all these like people who are very much you must do TTD and you must do it this way and you must do it that way, but nothing really gelled. It was there was too many options.
yeah, like I very much felt out of my depth at the start of writing my Scala stuff.
Oh
Um,
yeah, and Scala's a big problem because
but
there's so many ways of doing it. There's Akka, there's Java. You can just wrap Java very lightly. There's Play, there's type level, and then there's the Zio world, which I did find myself very quickly drawn to based on just the design of things. Um, yeah, mostly due to the similarities I felt to Polysemi, and then just how much I enjoyed that, and then realizing I liked it even more. Uh, pretty exciting. But yeah, the one downside being that this manual layer construction. So that's kind of what's a
yep, well,
good use case for
you
macros.
fixed it.
Yay! Hopefully, in
Yay.
some cases, I'm sure they're not every case in the world, but it's a good start at
So
least, and I think it can be.
is this in Zio 2.0?
It's going to be. Yeah, I mean, I have it merged into the Zio 2.0 branch. Yeah, but it's not
Yep.
quite there yet. Let me actually open up. Let me open up Zio itself because there's another. I wrote another macro, which just got released
Ooh,
as well, but that's in Zio now. The open source Zio idea.
you're a Flatland reader?
Sorry.
I said
Oh,
you've read
Flatland?
or watched
No, no,
Flatland?
no.
Yeah.
This is actually a library that Antoine. Oh, I don't know his last name, but it's the brother of the chief architect of Dorian, Sebastian Dorian, maybe Antoine Dorian, of Scala JS. He wrote a game
Oh.
using Scala JS, and I was looking at it for reasons for build file reasons, but it seems cool.
Yep.
I haven't played it. So he likes Flatland certainly. It's got a pretty delightful README.
Yes. I was going
But
to say it was many years ago that I saw Flatland or read about Flatland.
that's Terry Pratchett. Is that Terry
I
Pratchett?
can't remember, but
Okay, I've heard of it. I've heard of it.
yes. Like,
So let me run this
well,
test suite. This is another macro, and this was actually probably harder to write. I'm not sure. Um, but the idea is it's. Have you used Zeotest at all yet?
no.
Okay.
I think I can kind of loosely interpret what's happening, but
Okay. Well, yeah, these are the new assertion types. So the old assertion types. Probably going to talk about. Let me go to an example. Or something. Zeospec. Oops. CO spec.
So you can do property-based testing.
Yes, yes, exactly. So the old assertions look like this. You say assert, then you give it some value, and then you sort of give it a series of assertions. So equal to is kind of base one, but sort of these, it's this lens-esque syntax where if you say this got you an option of a list, then you could say is sum, and then inside of that have the assertion of the A inside of the option, nest inside of that, and throw an error if it were none, and it would sort of just show you the it was none.
Oh, right. Yep.
So it's this kind of thing, which is very powerful, composable, but just like the Z-layer architecture, like it's kind of similar, where it's very powerful and composable and lawful and makes a lot of sense, but there's a learning curve, and it can sometimes be more like, especially in the simple cases, it would just be easier to say like, what if I could just do equals equals, right? Or in some other certain specific cases, like why is it harder? There's definitely some cognitive overhead. So what we worked on was this, which is this assert true macro, as it's called now. It might replace the other one, where you just write a Scala expression. Like all this takes is an expression of a Boolean.
Yep.
And the way this works is, if I can get it to run, let me go to the bottom of this, and I will tell this to identity. Try to run this again. Maybe it can run. I don't know. Did it fail to compile everything? Maybe it did. Good luck. Good luck, compiler. Please work. But basically, this one, it's giving me some error here in some unrelated format. So I'll just try to do the term. But basically, what this does is this is a macro, and so it's that same format, right? Where the implementation says macro and then something, which is going to have something there. Current time millis is not something. Maybe that's actually my fault.
That's interesting.
That's because of, where am I? I'm on master. Odd. That's very odd. Java.lang.system?
Yeah, I was going to say, I'm pretty sure that system dot current time millisecond is.
Yeah, that exists. Maybe not on Zio, but something is weird with that. Anyway, I think that's just my IntelliJ being out of date. I'm going to go to project, test. No, I don't need you. Let's do tests. There we go. I'll run this smart assertion test. I'll show you sort of what the output is and explain what the deal is there. So obviously it's nice to write this, and one could imagine a very simple implementation that just is like, okay, this failed, and shows you maybe you could use a macro to just grab the code string. So you could say this failed, but
right, yeah.
But that's not like, that would be something to do, and there's some libraries that kind of work like that. And it would be nicer though to have something else, which is hopefully going to be revealed in just a second or so. Where basically you take this and you rewrite it, as what macros do, they rewrite code, but into something where it basically processes each segment bit by bit, stores the values as it goes, translates what would be thrown failures in some cases, like say 8 does not exist as an element of users because it doesn't have 8 users or 9 users. Then it would render hopefully an error message that is specific to that type of failure, trying to access, call apply on an iterable, likewise with exists and everything. So it's sort of like let users write normal Scala code, but then instead of having shitty error messages, sort of backport it to that other assertion syntax, sort of, that gives you more custom human readable error types. And I'm just biding my time here as it compiles. I have a lot of examples. I'll go to the bottom so we can sort of see what that works like. I'm actually going to get another seltzer water as that finishes up.
Yeah, no worries. Just reminded me that I have water too.
Hey, it's important to stay hydrated. Delightful.
Sure is.
So let's see. Wow,
Okay,
it's taking
let's
its time today. Probably have too many projects
Yes.
open. I usually do.
Yes, I also have done that.
How are you? I mean, are you enjoying Scala so far?
Absolutely.
Yeah.
Like, Scala has been. I was frustrated with Akka,
Oh,
but the
sure.
language itself is really nice.
Yeah.
And I think that's only because I suddenly found myself having to kind of simulate state in my brain again, and I'm like, this isn't why I came to functional programming. Like,
No. Console font.
oh,
Sorry.
referential transparency.
Exactly. Use console font instead of the. How do I do this? 18? Is it bigger?
Let's explore this.
There we go. Haha. Okay.
Yes.
Okay. So here's an example. So here's with implicit diff. So here I said assert true string, which is Sunday every day, is equal to Saturday today's. And so this is actually an example of also the string diffing functionality where this has failed because Sunday every day is not equal to Saturday today's. And it sort of shows the character removals and additions. And then
So
there's a
you
little
calculate
arrow.
the edit distance.
Yeah, exactly. Exactly. That's the edit difference thing, which is a little different. And then if there is no implicit diff right now, there's no differ for integers. So literally we say equals, but it gets rewritten as something that has a diff and has a different error message. However, if it's just an integer, which has no real good way of diffing, I could show like the actual number difference, I suppose, but that's kind of silly. Maybe that would be fun. 200 was 100 less than 200. But so here it shows that it shows two things. It shows that 100 is not equal to 200, so it shows like a friendly error message, and it also highlights the bit of the code string in both cases, that yellow thing, that was literally the code you wrote, int equals 200, and it highlights the failure. So up here, I say, okay, here I was testing it for quick check. So test failed after 2 iterations with input 800, because I said, this is that property testing thing. I'm checking for any int. I'm getting an int, and I'm asserting that int is less than 800. Obviously, that should not pass. And so, well, 800, it trunk it correctly as well. So 800 is the smallest reasonable value that is not less than 800, which is kind of cool. I wonder what will happen if I do rate it. It'll probably say 0. Yeah, will it try to find the largest value that fails? I actually don't even know. Oh no, I did IntelliJ. No, don't you don't do it. Stop it. No. I'm actually sorry. I'm just curious if it's going to say like 799 or something, or 0. Probably 0.
It might just give you 800 again.
Oh no, 0.
Oh no, there's 0. Yeah.
Okay, yeah, because it does sort of try to make it smaller. I think it's generally the thing.
Yeah.
And it starts out with numbers like 0. So anyway, that's the idea. I probably didn't need to run that again because. But anyway, so yeah, 800 is not less than 800. And then also this is another example of like here I wrote I had a negation, so I said not this, and it's a little strange actually if I pull out. Let me pull out this. Need to fix that. So I pull out the sequence and I'm accessing the second value. But the point is that if it was negated, the problem was that like 3 was equal to 3 is actually the problem here. And that's why it failed, because it got negated. If 3 wasn't equal to 3, everything would be good. So that's why it shows up as magenta.
Yep.
But the real cool stuff is like above, if I go to something that fails earlier, like let me go to sort of the top here. Where did I run it? Had a lot of things. Oh, there we go. Oh, there's the diff. Diff. Wow, lots of stuff here. Lots of stuff. Okay, here we go. So at the very top, I say, okay, the head stuff, whatever. Here's one that fails. So this is that 8 I was showing you before, right? Company users 8. So now it highlights the literal 8 because invalid index 8 for list of size 1. So it gives a very semantic sort of user readable error that's specific to the types, and it highlights the bit that failed, and it shows the values leading up to that, sort of from the bottom to the top. And likewise, 0 elements satisfy the predicates and things like that. Do I have any for each examples? Or for all? Let me see. For all, title equals high. Anyway, I won't search for that.
That's fair enough. Fair enough. Fair enough.
You get the idea.
Um,
But yeah, that's kind of how that
yeah.
one functions, and obviously it does this by this one actually needs to match on the real syntax tree and translate it into another format to like see like okay, was it a function application? Was it a? It needs to more intelligently basically do a case match on the AST that you get. So I know it's going to be some expression that returns a boolean. That's all I know. Then I need to take that AST, call match on it, and yeah, figure it out. So I have this like
So
parse expr method, which takes a tree and then turns it into this more generic AST, which is like either not and or it's a method call, it's a function itself, or it's just some raw AST that I can't parse any further. Um, and then it translate this into some other type, but it's you can like literally take a tree and match on it using quasi quoting. It works both ways, which is a really cool thing about matching in Scala, that it sort of is the same thing both ways. So this literally will unmatch the left hand side tree and the right hand side tree if I call and then I get to build an AST of and recursively parsing the left hand side and the right hand side.
So is this basically like you'll unfold a syntax tree, you'll
Pretty much.
then you'll just kind of carry out the evaluations and then go back up.
Exactly. So I unfold out an AST and then I sort of fold it back an
Yep.
AST to an assertion. So I build a new tree
Yep.
where I go the
Yep.
other way and I call this assertion syntax, which I have all these assertions that are very specialized. So I have as right is some, and there's this special like combinator library underneath it that represents each segment of the thing. So it turns each like company will be one thing, and then users will be this little individual segment that plucks. It's like it's a function from company to users. So it like pulls out. It's an arrow syntax essentially. Um,
Yep. Oh, yep. Yep.
and it can fail. Each one can throw up. Each one could throw up an error, and then it'll get sort of reported intelligently, and it'll trace its path and of failures, and it'll sort of you can eventually run it, and it will and each of these contains sort of this is where the error messages go. So is empty iterable? It calls is empty on the iterable, and if it fails, it's going to have this message, which is I get the class name of the thing, so it'll be like list was or was not based on whether or not it was negated. So it's like this mini DSL here that I made. So because
Yep.
it has to be magenta if it was negated, and then it was not empty, and that's why it failed, or it was empty, and that's why it failed. And then I say like I get the size as well, just to have nice fancy things. And yeah, so that's kind of how that works. So I have all these assertions, and so I need to translate certain methods into them. So I have this matcher thing, which is
Yep.
this unapply method that takes an AST of a method and turns it optionally into this assertion AST. Um, so all are all of these is even, is odd, equal to, greater than. So these are like the hard coded specializations. So is empty iterable is an AST. I have this AST converter, which if I get an AST that has the is empty and the type of the left hand side is iterable, then it's going to turn it into is empty
Oh,
iterable. And
nice. Yep. Of course. Yep.
so it's this like nice, so I can add them sort of semi minimally, but just by doing this. Obviously, I tried to get this to work with both Scala 2 and Scala 3, but it turns out I probably could get it to work, but it was Scala 3 cares a lot more that it has a hygienic macro system, which means that like here with Scala 2, I could basically just plop down any old. I can call any method on anything, and it'll break at compile time if it's wrong. In
Yep.
Scala 3, I need to prove that as I'm making the code, it's right then. Like I need to show that the types are already correct. Whereas it's literally more in Scala 2 like string programming, where I can dump out a string and then it's going to compile it again and say like, oh, this actually was wrong, which actually is easier in a lot of situations. It's a trade-off though, because then
Yep.
you
Yep.
can't do
Yep.
certain fancy things that it is able to do. Um, so yeah, that's kind of like those are the two flavors of macros I wrote. This one is definitely more complicated because it needs to actually parse out these things, and you kind of got to learn the shape of the tree of Scala. But it's actually not so bad. It's yeah, there are these different types of nodes. You can't always just rely on this because sometimes it's more complicated. So here I made my own unapply method for method call where I like actually no with Scala 2 it's all right. Even though I'm translating lots of things into method calls because I didn't really care whether or not it was an actual method call or just calling a method or just selecting a property. But you need to sort of match each separately. But I'm turning them all into the same thing because I didn't care. Uh,
Oh, yeah, fair enough.
and it gets pretty ugly because like if there's an implicit that was automatically wrapped, like if if say you call like an either ops, then you're going to get that either ops in the syntax tree. But I don't care about the either ops,
Yeah.
uh, and so
Yeah,
I
fair enough.
want to actually remove that. Anyway, it's it was fun. But yeah, that's kind of what I know about macros.
Yeah, no, fair enough.
Obviously,
I'm
it's a
gonna
lot
need
of
to
bullshit as well. Uh, yeah, and there's some other crazy stuff you can do.
what's a good place to start actually reading about this? Because I've never attempted to tackle macros in Scala before.
Yeah, so
Um,
there's definitely this the Scala. Okay, cancel. There's the Scala macros guide. It is very much sad. Yeah, def macros. So these they're yeah. And this guide is kind of out of date. It's still listed as experimental. I guess it is technically experimental, and
yeah.
there are too many gaps. Frankly, like it's not. It wasn't the best. I think the way I learned about it was literally like, okay, I would like this to work. I have this very specific goal. I need to do this. Basically, what I need to do is get the types off of these things. Can I do that? And then kind of like look to see what functions existed. The very basic is just like
Yep.
make a macro type and sort of do those C expert things. But yeah, this guide is definitely one of them. Let me send a resource.
Thanks.
And then also Alex Ayafi made some great videos on YouTube. He did like a whole series on playlists on yes macros, which are really great. So let me send you these. This is mostly I think on Scala 3 macros, but it has the same sort of concepts. And Scala 3
Yeah,
macros will
that's
be
all
more
right.
useful in the future.
Yeah.
He's a funny guy. But yeah, there's that. I probably am gonna start to write another macro soon. I guess I did do some other ones as well. I've been addicted to them lately because yeah, I like not writing a lot of code, and so I want to figure out all the ways to write the macros so I don't have to write a lot of code.
Fair enough.
One of the things I'm trying to do next, and maybe I'll do it live. Maybe I'll stream it, and I'm happy to invite you if you're around.
Yeah.
I'm not sure when I'm going to do it, but probably soon. Is the let me go. Let me close all these projects. Okay, this one. So one thing I did do, one other macro I made was this. Let me go to this examples business. This is this like derive client and derive routes thing where get
Yes, I
did you
was. This was the one that I was following along to.
okay in the videos.
Yeah.
Yeah.
It was very good.
So yeah, it's pretty cool. It's pretty cool, and like I extended it to work with now Zio streams and failures. So it'll basically I can call this event stream. So here I have this in this shared folder for the full stack app. This trait. So one of the functions is event stream, which is a stream of either it'll fail with an int or it'll give you an event. And on the front end, I call event stream, and then I call retry. So if it fails on the back end, it's actually going to serialize that failure, send it to the front end, and it's going to actually fail that stream. So you can retry it, and when retrying, it'll re-hit the back end and start it up again. So it kind of acts like you were all writing back end code, and there was no serialization. I hope, in most edge cases have been satisfied. And on the back end, likewise, you just say derive routes, and then you just create a version of this example service. And I have one for events that just like uh, repeats an effect. So I have this get a random event every 100 milliseconds, and it just sends them out. I probably don't need that anymore. Bugging something. And yeah, and that works pretty nicely. But I was kind of along, and I'm pretty happy with that actually. Now that I can do all that stuff, I think it's mostly done for what it is. There's definitely other use cases, like what if you actually want like a JSON API or something, or want to configure it? I need to work on that.
Yeah.
But the next thing I wanted to tackle was like querying databases and making that nicer.
I
Because
see. Yep.
have you used stuff like I don't think you said you didn't use Quill, but have you used Slick?
No.
Have you? What database libraries have you used for Scala, if any? I'm not sure.
Like literally nothing.
Okay, great.
Yep.
Yeah, no, it may not. Not all apps have database libraries, but yeah, there's Quill, there's Slick, there's Doobie, there's stuff like that. Basically, all of them, and in Haskell as well. Have you used Ruby on Rails or any of those types of frameworks?
I have kind of, I guess, played with them, but never really used them seriously.
Okay, so what's nice about them? The cool thing about dynamic programming languages, one of the big benefits is they don't need to conform to a type system. And,
Yeah.
and a lot of times you could forget like where's that useful. Well, it's when you do things like in Rails you can say like user dot whatever all, and then you could say include posts. So this will, if the user on the user definition has this like has many posts field, it will get you. It'll return a bunch of users that have inside of them all of their posts already prefetched. So it'll like automatically figure out that this is like a it has a post has a foreign key. You've written out your data types in a certain way, and it doesn't need to like figure out how to represent like what's the difference between a list of user and a list of user with posts. Like how would you do that in Scala? Like how would you change the type to have a different type? That's that. I mean, maybe it would be like a list of user with like a list of posts or something. But how do you then keep operating on? This would have to be like a query of that or something. Like it would be painful.
Yeah, for sure.
Possible, and I want to think through that. Obviously, it's part of this, but like it's kind of magical. So there are these. That's called an ORM. These object relational mappers. Can be really high level and nice and get you these relationships and in a nested way and through join tables and all that. Because they can just dump it in there. They don't need to worry about the type. It's just there now. Okay, now you have posts. And if they weren't there, it'll blow up. Whatever. Who cares? But we don't like to do that. So what we do is we use so there are libraries like Quill, which is do I have query something? Let's see, query. Where do I have an example of this? Yeah, so here here's a Quill query where I can say like query post, and this will it's very clever. It uses a macro to figure out that okay, let's assume there's a table called post in the back end. I will query that and I'll inspect all of these fields and assume they line up to column names, and I'll turn them into camel case, and I'll fetch that, and I'll back up into posts for you. So this will get me this query of posts. But if I want to get all of its post users, I would have to do something like, where all the post comments. I would have to get all the posts, and then I'd have to get all the comments by sort of saying like a query comments. This will actually get me an individual post, field post, query comments dot where. Is that right? Filter, and then I could say like
filter,
post
I think,
ID is equal to post and stuff like that. And
Yep.
and so what I'm going to get back is sort of the Cartesian product. I'm going to get back the tabular data, like just like you were querying SQL. So
Hey.
and that was a problem in Haskell. That was a problem in I used in Haskell Esquelito and these other libraries. Like the beautiful quality of life solutions that exist in libraries like Rails just not only do they not exist in functional languages, like no one even complains about them not existing. I was so confused when I first used Haskell. Like, why is there not a solution? I thought you guys are geniuses. Why? Why don't you have something like this? And why does no one even care about it? Because I don't know. People just different world. People use Haskell probably didn't use Rails, and so they don't know that that's even something that you might want. And they just deal with the aggregation. There's all this aggregation code where you have like, God forbid, you have a triply nested thing, or you have like multiple fields, or there are left joins. Oh my God, now you have options. So you have this like giant tabular list of a tuple of a user with an optional post with an optional comment, and like each user is going to be duplicated like 80 times for each comment, and you want to aggregate it, and it sucks. It's probably not performant either because you're getting all those case classes that are redundant. I don't even, yeah, no, there's probably a really better way to do it. But one thing that I want to do is explore a way to make that less less shitty. And I'm not entirely sure of the way to do it. There are some cool libraries. Adam Fraser wrote one called zQuery, where which is very cool because it lets you batch up things intelligently, like as long as you're inside of this sort of zQuery structure. So first, I'm gonna like get a user of a certain that has an ID of greater than one. Is this even gonna work anymore? Oh yeah, I'm doing weird stuff. Okay, no posts. And for each of these users, I'm going to map over it and get its post, which is another Z query. So you'd think, oh no, this is the n+1 problem. For each user I get, I'm going to make another query.
Yep.
But in fact, no, it's only going to. Okay, there's a. Oops, I have example code. I'm just going to comment out. But no, it's to batch it up intelligently because that's the magic of zQuery. It's going to like batch and pipeline this information. So it's actually only ever going to make two queries, one for the users and then one for all the posts.
Oh, right. Okay, nice.
Which is one of the cool potential solutions. There is some boilerplate involved. So that's kind of, once again, where I'm thinking, okay, macros maybe. Maybe we could do some macros to get rid of the boilerplate of like, you have to make these request types and you have this data source and then you've got to like translate it down. It's not the worst. It's definitely worth doing if you have a large application and it becomes easier to extend once you have the boilerplate in place. But here's the example. At first I made one user query and then I made one post query and then I got back intelligently sort of nested everything that I needed. Yeah, I think you could even do like user with post or thing, and then just you can write out an individual method that looks like it first gets a single user and then gets that user's post, and you're going to get back, if you run this on multiple times, it's still only going to make two queries, one for all the users, one for all the posts, even though they're sort of cleverly nested. Also because it's two queries that won't do this sort of Cartesian product creation of case classes, which is likely not performant. But I'm not really sure. But I don't know the best way to solve this problem in a generic way, and I'm thinking of exploring it with macros. So that's kind of like my next. That's the next problem.
That's the next project.
Yep. That's the next thing I'd like to look into, the active record solution, and like what is the right balance between, cleverness and actually something people are going to want to do. Yeah, I'll probably stream that whenever I'm getting into that. Yeah, a lot of things to explore.
Just drop a link, and if I'm sort of awake and in this, in the appropriate time zone to check it out, I will.
Okay,
that's rad.
Awesome.
Oh dear. I don't know. It's very exciting, but at the same time, I feel very out of my depth.
Well, yeah, I mean, I felt that way too. I remember when I first looked at macros. I was working when I first started Scala, which was 2.5 years ago, I think. I forget. For the first year I used Scala, like I sucked at it and it scared me. Like I thought I was good at Haskell, so I was like, this is gonna be easy. And language is dumb. I don't care about it. It's because it was all this, implicit errors all the time and this cat syntax that was just so much worse than what I was used to in Haskell. And just like, how do people write? Why? Like, I want to use Haskell. Why do I want to use this? And I think that's why a lot of people were sort of driven away from Scala to Haskell, because it's like, why would I? There's no type inference here in Haskell. It's great. You don't have to do all this stuff like widening and narrowing, and it's like, oh god, Scala just doesn't even work as a language. Until I found Zio, and I'm like, wait, it can work as long as you use variance annotations, and then it actually becomes better than Haskell.
Yes.
For me, at least. I know people have different opinions on this, but that's what I got so excited about it. But I sucked at it, and I remember like looking at, there was some macro code. We were using some GraphQL library called Sangria, and someone was like, oh yeah, just extend the macro library that we have. We'll just write a macro. And I looked at it, and I was just like, it's the ugliest thing though. It's so like if you're not let me go to someplace, black box context, right? Like this code looks insane. Like what is this C black box context? And then you're importing C universe, and then there's these C weak type service. It's like Decals. It has the worst like there's no documentation. It has this really horrifying syntax. It's not normal code. And like you can't just call this function normally. You've got to like call this macro keyword, and then there's like some black box context. That sounds spooky. So I was just horrified of it, and it's sort of just like was like, I'm never going to learn this. Maybe I'll learn Scala 3 until I had the idea to do this thing. And I was like, okay, let me sort of dip my toes in slowly. I actually didn't go right to even writing the macro. First, I tried to use another library that seemed like it might work and like kind of failed for a while. And so I sort of went slowly back into it.
Yep.
And so you got to start slowly. I mean, just and that's like now it's really complicated because there's a lot of code here. I think I'll definitely invite you because starting from scratch will probably make more sense instead of just like, okay, I just dove in and walked you through what slowly ballooned to be as you deal with real life use cases, as you deal with bugs. You've got to take what was a nice, elegant, simple core, and it gets bigger and bigger and more complicated. But
yep.
at the beginning, it's really fun because you don't really need much. You just need to prove a concept, and then you can blow it up with real world resilience and all that.
Fill in the actual stuff that needs to be there for it to work in a large way.
Exactly. So yeah.
Okay, that's encouraging. That's good.
So don't be scared. No, man. I mean, if you can already follow along here, if you're already translating Akka stuff to Zio, you are way ahead of me in your Scala journey than I was at 5 months in. I was like totally checked out and scared and bored. I didn't know what implicits were still. I was just like, why? It took me so long to figure out how to get, like I would copy paste code from another file and why is this not working anymore?
The implicits would be like, what have you done?
Yeah, and this
was I don't have an execution context.
Yeah, and it was before IntelliJ like had its little helper to, hey, like clever figure out what you need to import. So I was just totally lost. Because yeah, there's so many different words, like, and there's so many different styles, and God forbid your implicit's defined inside of like a trait, and then like now I don't even know what to import anymore, or if I can import it. It takes so long to figure out all the paths that code could possibly exist in. Yeah, it's quite a large language. It's quite insane.
I've not had fun with implicits, by the way. There's a lot of.
Well, yeah, I mean, yeah, I might talk about that sometime too, because there are a couple of rules that sort of make it a little easier to get a hold of.
A little more, yeah. I mean, like really, I only want it to kind of be more manageable, not.
Yeah, and then there's also the tricks that you can do with it, right? All the shapeless stuff and using implicits with the aux pattern and stuff like that. And it's like, I guess Scala 3 with the whole purpose of, well, one of the things they did with it was just like break out all these different purposes into like different, just even different names. It's all the same underlying machinery probably, but this one has a different name, this one has a different name. Because generally like the same 10 concepts would be combined in, 1,000, combinatoric explosion of ways. Only 6 or 7 of them are useful, but it becomes like you have to memorize those. Once you memorize those, and once you've used them, you're like, oh, it's just a pattern, and you just go through the motions. But it takes you've got to practice that. Otherwise, it just looks like noise. And like, why is this different than that other way of doing it? So, but hey, but yeah, that was really fun. It's nice talking. By the way, what should I call you, Janus or Darcy or? Darcy?
Whichever you prefer.
Okay.
Like my name's actually Darcy, but you can call me Janus.
Yeah, you can use your hacker alias. I don't mind.
Yep. That's my top secret hacker alias. You have to have one. Like a lot of what I did before dev was like I made like third party cheat software for a lot of games. Sorry if I ruined anything for you.
Nice. That's a good inlet. No. Yeah, right. Unless you made like cheat software for like Solitaire or Frogger.
I did not, but I could.
What? That's cool stuff too.
So I started doing that when I was pretty young. So
you use like Game Shark. That's what I used back in the day. I was
yes.
I don't even understand.
I did use a Game Shark.
Wow, that was insane. Like you had to plug in your game above. I just forgot about that whole existence of my life. N64 Game Shark. I was like 12 years old or 10. So weird.
I miss the days when there was no memory protection at that was those were the days.
It still blows my mind. Maybe you could do we could trade some knowledge. I would love to know like all those sorts of like it's not decompilers, but where you're like looking at the memory. Yeah, I'd love to know how that works because it's freaking crazy to me how you hack into some things like binary and like just know how which memory flags to flip, and that doesn't just blow up the game in insane ways.
Oh no, absolutely. But like raw hex editing is still magic. Like it takes a lot of
It's pretty
it
cool that
takes a
people
lot
can
of
do it.
experience to be able to do it. But like, what's the word? These days, like I've written a couple of like code disassemblers for x86, like not actual serious ones, just toy implementations. So I could figure out how it worked. Like
That's awesome.
that's very much my I kind of there are a bunch of books that I would recommend if you're interested.
Yeah, no, that's a whole area of computer science that I've sort of levitated towards the celestial macro Haskell type of level world, and I have some low level stuff, but it doesn't really go down beyond like you know byte arrays in very constrained circumstances. Certainly not like machine code. I did read NAND to Tetris, or at least half of it. If you've ever read that book,
I have not.
that's pretty cool.
What's
That's very cool. They have you build logic gates in an HDL language, and then they work up like you build Tetris. You go from NAND gates to Tetris is why it's called NAND to Tetris. But it's very beginner and very fun. But it's certainly not
oh
like
nice.
actual x86 low level funky hackery.
No, fair enough. But that is very cool. Like building the stuff from actual NAND gates is great.
It's
Like, and actually understanding how the
it's very neat. It's very mind blowing. I still don't really it still feels like magic, but it's I highly recommend that book too. But no, send me. I'd love some links if you have. I'd love to read something about
Oh yeah, hang on. I'll just I wanted to send you the PDF, but it's too big.
it.
Um, so this is a book that I came across recently that is just really good. Um,
Oh,
it's called Practical Binary Analysis.
practical binary analysis.
How large is this?
Practical binary analysis. That sounds amazing.
Yes, it's a fantastic book.
I love that name. I will. I can find a copy. I'm sure. Build your own Linux tools for binary instrumentation analysis and disassembly. Nice. Oh, and it seems like perhaps
Yes.
is the go with the cover, but I'm not sure.
Yes. Like I was very much into reversing, but I did a little bit of exploit dev too. I don't have as many good recommendations for exploit development. It's just kind of something that you
you discover.
yeah, you kind of have to pick up from doing it. But like the only annoying thing for me was actually having an environment set up where I could easily kind of test exploits and compile basically turn off all of the compiler flags that make it safe. And then reintroduce them as you want to do different levels of obviously you kind of can't just do classic after overflow stuff anymore by default.
Sure.
There are a few clever things that even the C compiler puts into the stack, like what's a good example? So what do you have? First of all, the stack is set to non-executable, which was a good decision. I have no idea why that memory was ever executable. There's a bit called a canary, which is like a random value that's checked after the stack frame comes back. So sorry.
I said, oh, that's clever.
Yes, but kind of easy to get around if this canary is not random. Because for a while I think it was just a 0 or a 1 or something, and so when you were overflowing, you just write the correct canary back into the.
That's hilarious.
And then there's ROP, and ROP's my favorite, which is my favorite way to get around the non-executable memory thing. Which is basically that you find little chunks of assembly in an attached library or something else where you can be sure of what the memory addresses are, and you'll jump to that address, or rather you'll load those addresses into memory so that as it's kind of going off the stack, it'll go, oh, there's an address, I better jump to that. It'll execute it, and no matter what it is, if the little assembly thing ends with a return, it will pop the next address off the stack and execute the code there. And then get to another return, go to the next address. And so you can make arbitrary programs like out of chunks of other programs as long as they end with this return thing. It's fantastic.
So you're like
I
literally,
know.
it's like a ransom note. You're like cutting out like little instructions from this program. And
Like literally, it's just like cutting out the bits that you want and assembling them together. Man.
Oh my
This is my
God.
program now.
That's pure insanity.
Maybe
we could write a macro for that. That would be.
Well, I think you probably could. People have like ROP chain generation is sort of non-trivial because you can't have any null bytes in there. You can't have any zeros, or it will.
It certainly sounds non-trivial to me.
Yeah.
You don't need to convince me.
I'm not going to go into it too much now. I've got. Oh, hang on. I've got a good. This was. Pardon me. This was an online night that I attended one year. I think most of the resources are still here. So that has a bunch of amazing resources for like I particularly like the stuff on reversing. That was great. But everything there is good. Like,
yeah, I mean, this would just be great to learn more about how the computers actually work instead of all this high-level language nonsense, and really break the things apart into their constituent components. That's exciting.
I don't know. Maybe it's a grass is always greener thing because I definitely want to learn more about the high-level stuff.
All right. Well, I'm happy to do this again sometime. Oh wait, why am I posting it back into? Yeah, here I'll post it back unnecessarily.
Thank you very much.
There you go, buddy. But yeah, I gotta run in just a minute, but that was super fun. Let's totally do that again sometime.
Yeah. Let me know. I'm around like most weekends. Obviously, I can't do it at work, but
sure.
But some days I'm working from home. So
awesome.
Alrighty. Cool. Good to meet you.
Yeah.
Oh, actually, hang on. If you have a sec, there's something that I'd really like you to help me with.
Oh, sure.
It's been confusing me for.
Oh, please, yeah, no, totally. I can I'll give you one last get at a free card.
Alright, let's just quickly open this. Hang on, I'm going to share my screen.
Okay, and I'm still, by the way, on the Twitcher thing. Would you like me to stop that? I'm not sure if that matters, or we could share the knowledge with
do I have anything compromising up?
Our two viewers.
No, I think I'm okay.
Awesome. All right, share your screen away.
Anyways.
Woo!
Yay, IntelliJ. All right. So I was doing Zio exercises. And this.
Well, I only see a dark void.
Oh. This is. Hang on. Maybe give it a second.
Gotcha. I see your mouse, but not. I guess the program.
Okay. Who knows?
Maybe if you minimize the window.
I'm just going to stop that and let's just share not a particular window, but share the whole thing. Alrighty. Got everything?
Still a dark void. No.
No. What is this?
Maybe just cancel it and try it again. I don't know. That sometimes it's. I still see your cursor. Could you post a series of screenshots to Discord?
Oh yeah. I'll just do that. That's easier.
Okay. It's just some code string.
Yep. Let's just grab this. Oh, also let me know if you ever want to know anything about mathematics, because that was the other half of my degree. So.
Oh, sure. Yeah, absolutely. No, that's the other area that I'm. Well, there are many areas where I'm profoundly ignorant in, but okay.
Fair enough. Okay, so what the heck is going on here? Like, I wrote this, and I know what I was trying to do. Like, collect all just makes me think of, lifting the thing into a monad or into an applicative or whatever, and then folding right. Well, Oh, sorry, folding left.
Are you
rather.
making your own Zio? Is that what Yeo is not a type alias? I'm familiar with.
This was one of the exercises in the Zio book, the Zionomicon.
Nice.
And the idea was basically with a kind of toy implementation of Zio, with nothing but the run method that takes the environment and returns either error or A. You're supposed to re-implement the collect all method.
Okay. I see. So, okay, yeah.
Yes.
The signature
so
makes
for me,
sense.
The type signature makes me think of like sequence from Haskell. So I tried to do sequence, but the problem is down the very bottom.
Yeah? The with
where
left E bit?
I've done the fold right with a right of an empty list.
Okay.
And then I've had to do this little with left E thing so that the type checker doesn't explode.
Yeah. Actually, just one sec. I need to run to the bathroom because I drank too much seltzer water. So I'll keep the screen up. I'll be right back. 1 sec. Okay. I feel much better. All right. It was hard to focus for a second there. Okay, so I see. So so Yeo exists, and okay, so you have this run method. Run takes an environment. I see. Okay, so it's kind of the in the toy example, I'm guessing it's literally sort of that denotation that they sometimes refer to. It's literally a function that takes an R and returns an either a V and A.
Yeah, exactly.
Okay.
It's like this is the way that you think about it, but not actually how it's implemented.
I see. Okay. So so the goal here is so that's why you're operating on these ethers. So what's the problem with it? Is it the actual like just getting the type to work there with the with left, or is this working?
I literally just want to know if this is correct. I have no way of knowing.
Can you
this going to do what I think it's supposed to do?
Are you able to run it?
Well, I mean, at the moment, I'd need to actually kind of fill in the fill it all in with actually meaningful stuff. But if I just kind of put it with a right of an empty list of A, it will fail as it will infer right instead of either. So I needed to add with left E so that the Scala compiler would infer an either.
Could you copy paste the actual code to me, and then I want to run that in share my screen.
Yeah, absolutely. Does Discord have any code stuff?
Oh, you just copy paste it as it is, because I'll just
okay.
Cool. Make a new little object here, and I'm going to copy your code.
Because my issue with actually running it is that I'm not sure what with left does when I actually try to fold that with a right.
Yeah. Let's take a look. I'm not entirely sure either. But it looks like so this is run, which is a method from R to either EA. Is that correct? Okay. So let's see why is anything said? I probably missed. Okay. Oh, there's the underscore there. Maybe. I think it probably turned underscore.
Did it not copy those?
No, that's fine. Maybe because it thinks underscores are italic, so it probably turned it into italics.
Yes, that'll do it.
Silly things like that. But besides that works fine. So there's this join either, which takes a name. Can this be abstracted out? Yeah, pulled out.
Yeah, that can be put
Okay.
anyway. I just
no, it makes
I
sense.
just put it there. Yeah.
So let me put that there. We want to return a new EO, as is the case here. Oh, yeah, so it definitely is not happy with the E. So what I do in this case generally is a common problem for sure. What I do in this case though is actually type this. So it's either of E list A, and then you could put the right in there, and that should work.
Oh, I had no idea you could add the annotation there.
Yeah, so the fold right is parameterized by the huge annoyance, definitely in Scala, the fold right type ascription stuff. But instead of doing it internally, because it can be nice with some types, but not like with. I don't think there's an option empty, but it's not even an option empty at this point. You want the it's not an option; it's an either. I don't think there's any sort of type on either that even lets you do that. I get did the with left, is that even a method on it? With left. But this like has to be less than or great. Weird. Yeah, I don't even know.
Yeah, it has to be a super type of.
Yeah, so yeah, that didn't even work right. Okay.
That's what made me so incredibly confused. But I was like, well, it does lift it to the appropriate type if I do this. And it actually compiles despite IntelliJ complaining. I just don't think it will have the runtime behavior that I want.
And this is interesting a little bit too, because I think this one won't short circuit as I think you've done it currently, right? Am I crazy?
It won't short circuit
because of the fact that you're calling it first like this. Because you're going to get first. You're making a list of eithers, right? Like what is this? Let me get this.
Yep.
Val eithers. Right?
Yeah, that's some eithers.
So you run each one. Maybe I think the actual collect all semantics will fail upon the first. I mean, this is only a toy, so it doesn't really matter. But the way as well would just be to do in fold right, and then inside of here, B is now going to be, or rather, A is the YEO. So you could say, B match whatever left. If it's left, you would basically just percolate the left value along. If it's right, then you can do R. What is it? A dot run with R, and then you get the either, and then maybe.
I see.
Yeah. Yep. And then silliness here. It's gonna get increasingly ugly. I'm sure there's a nicer way to write this, but type pattern value left pairs, and then the right, and then it would be the A's. Is that unhappy?
What's wrong?
So it'll be a right of A's dots whatever plus A, and then this is a left, fail, left, fail. There we go. Okay.
There we go.
I don't know why it's sad, but I probably screwed something up. Maybe this has to be a block. So sad. This needs to be there. Okay, I was right. Yeah. So super ugly as it sounds, but I guess I could just do map here.
Right.
But hey, yeah, you get the idea. That would short circuit, but same thing. Even though there's also validated or validate all, which gets you a list of errors back or something like this. So you'd also, your version could be nice to implement that with, where you run.
If I actually wanted to get a full list of each of the errors that ran for the effects.
Yeah, but there's another cool, one of the really nice things about having a full sort of class up, thing like this is that if you wanted to make that in a cheaper way, if YEO say had a def either method on it, like either basically is a function that takes YEO R.
I saw you do the Haskell / annotation.
What did I do? Did I just screw up?
You did the double call on it. I was like, it's Haskell.
We're back, baby. This would get you back an either EA of and then nothing here, right? And so if this method existed, which it doesn't, validate all would basically be the same signature.
Yep.
List E, and this is sort of like a hack doing it, where you take your in, you map, you call either, then you call oops, validate all. Then you can call collect all on this, and then you can sort of do some sort of literal map on this or whatever. There's no map, but then you could call like partition and separate out the either, and then have two lists, which is kind of nice. Well, I guess this would be more of nothing lists and then a tuple of list errors, list of A's. But anyway, hopefully that helps.
Makes sense.
Yeah.
So is the idea basically that like in the first implementation, sorry, in the implementation that you've redone, as soon as we kind of hit the error, we short circuit and we jump out of the fold. Like we know that we can just return that E.
Yeah, actually, I guess it's technically not. It's still, I think it's the real way to do it performantly would be to make your own loop function that does it, because this will not actually short circuit. It'll keep building new lefts.
It'll keep folding
it'll keep folding the whole way. So fold right's not great for short circuiting, but we'd have our own inner loop that does basically the same thing manually.
Would it be better if we did like fold left?
They'll both keep going to the end.
Okay, rats. Yeah.
Oh, okay.
Oh, fair enough.
Just got a little ding ding. So I'm probably gonna head out, but I would love to do this another time, and I'd love to pick your brain about math because I have so many math questions. I've tried to. Yeah, we'll talk again.
Yes, please do. And just feel free to message me on like on Discord as well. I'm usually around, so.
Okay, awesome. Yeah, and I won't always go.
Cool.
We don't necessarily have to record it either, because I was just trying to, I thought maybe more people would want to know about macro stuff. So leave that stuff for the world.
But they should, but they missed out.
But no, except for Sadash. So thank you for being here, Sadash, and I hope that was entertaining. And yes, and to posterity, thanks for joining, and to Janus, thank you so much. It's great to meet you.
Good to meet you, Deacon. Okay. Thank you.
Take care.
See you later. Bye.